Hello and welcome to this video where we'll go into more logical and physical modeling. When in previous videos you have seen me gone into conceptual modeling, which was closer to business. And in conceptual modeling, we model the real world into entities. And when we come into logical and physical modeling, we add more details and getting it more implementation ready to specific databases. So I'm here in the keynote, going from a conceptual business-centric modeling to logical and physical modeling that are more technical. So modeling, we go through several steps, right? So we start always in the business and then we go further and further closer to the technical and into implementation. So usually you don't want to implement directly. Instead, you need to go through these various steps. So data modeling journey for transactional data. You've seen this in previous video. So we have business requirements and then entities, relationships, conceptual model, logical model, physical model, and after that is implementation. So the top three here, and now we'll go into the bottom two. So we have logical modeling and then we have physical modeling. So in logical modeling, we add attributes such as primary keys, foreign keys, and we normalize the structure. And then in the physical modeling, we convert a logical model into database structure, choose the database engine, define data types and the constraints. And now, in the logical modeling, we have the normalize the data, the structure. Actually, we won't go into the normalization in this lecture. Instead, we will have another lecture which focuses on the normalization. So then that is a little bit the larger part. And also we have another lecture on the primary keys and the foreign keys and a lot of other keys as well, as this is a large topic as well. Remember that this goes into the logical modeling. Remember the business requirements that we had for ice cream. So we have these business requirements, but basically we have an e-commerce that is selling ice cream and you want to be able to order ice creams, right? And based on these business requirements, we got into the conceptual modeling, conceptual ERD, so conceptual data models for ice cream using Krauss foot notation or information engineering. So this is the model that we got. So we have a one-to-many relation and we have a many-to-one relation and the order entity is a associative entity or a bridge table, right? Or it's also called composite entity. There's a lot of names for this. Composite entity is an entity that resolves a many-to-many relationship between two entities, because if we had like customer to product, then we have a many-to-many relationship. We can't implement it directly. So we need to have a composite entity that takes care of this relationship. The composite entity is the relationship entity and it contains relationship data, which can be both the keys and also some additional attributes. We'll see example of that. So it replaces a many-to-many relationship with with two one-to-many relationships. So you have here a one-to-many relationships and you have here one-to-many relationships, right? So we have two one-to-many instead of a many-to-many. So it acts as a bridge table. Then we have already implemented and we got on the table. So it's a bridge table and it has foreign keys that references primary keys in the related tables. And also you can see this table as it's a child table that depends on the parent table customer and the parent table product, or you can call it related table. So there's several names for this. So it's a child table because it depends on the parents. So it depends on the parents which holds the primary keys. So going back to this relationship or this business requirements, we can go into here. So here is more details now. So we have attributes in customer entity, and the attributes are a name, contact details, and delivery address. Can you find the attributes of the other table, the other entities as well? If you haven't, just follow along and see here. So here we have attributes in the product entity, and it's the name of the product, the price and availability status. And then we have attributes in order entity. And we have the ice cream flavors, right? So these are some attributes that we have, and now we will add the attributes in our data model. So we go into the logical data model, and here we have attributes as well for the order entity. We have order details, order date, total price. Some of them might not be exactly what will be in the attributes. For example, total price. Instead of total price, we'll have the quantity. I'll show you why. So the logical data model here. And for this, I have used Lucid Charts, so the diagramming tool that I showed you in a previous video. So here we can continue with Lucid Chart. And basically, this is the diagram, and you have customer, order, and you have product. So they are the three entities, and you add all the attributes below here. So difference from the conceptual model is that the logical model also contains the attributes. This makes the model more specialized, while the conceptual model, it reflects the real world in general terms. So it reflects the real world, while in the logical model, we come into specific applications. So in this specific application, a customer has these attributes. In the logical model, you're talking about the three entities, customer, order, and product, and they could contain a lot of different attributes. We're not sure. But for this, when we come into logical, we have specified which attributes they should have. And this is tied to the specific application we have. So that is a huge difference between a logical model and a conceptual data model. Logical data model, also called LDM, if you abbreviate it, which some people do. And the physical data model for eScream, and here we use a tool called DB diagram. Actually, you could continue with Lucid Charts, but I really DB diagram because this uses a language called DBML, and we'll go into that soon enough. So then you have something called diagram as code. And when you have it as code, you can always source control it. So that's a huge benefit. So it looks like this. And now you can see a lot more details. This is the physical data model. It looks similar to the logical data model. However, we have here specified the key, the primary key for custom ID, the primary key for order, primary key for product, right? And we have specified the data type. So this is the domain constraints. And we have specified not null here for those that are not null. And also the keys they have the primary keys, it has this property that it should not be null. Okay, and here you have one-to-many and one-to-many. And also we can see more details here. Customer ID, this is the primary key. And this column, this is the domain. And so the domain is defined here. The domain is all the allowed values. So here you have varchar 255. That means the domain is, you can add 255 characters and not more. And you cannot put in other data types. So this is, it must be a string, right? And another question that arises quite often is that how many you should choose in varchar, and it depends. So I've searched up like emails. It says 254 is the maximum length of an email allowed. So then we have 255 characters. And also you can check depending on your system, and you check most of the things that you look it up. So for example, addresses, you don't have that long addresses. So I've looked it up also, and 100 is enough for that. This one is actually one and only one in DB diagram. In DB diagram, the convention looks a little bit different from what we had in Lucid Chart before. And that's fine as long as you know what you mean. In DB diagram, you have a zero or a circle that represents 0 or 1. So optional 0 to 1 is marked with circle, while we have mandatory 1 and only 1 is with 1 bar here. So this is just, so you just need to know that it's a one-to-many here, one-to-many. Okay, so this is how the DB diagram looks like. And the DB diagram, all right, we have this one also. So foreign key references to primary key. So here you can see this is the foreign key. It references to this primary key. One very important detail is that the foreign key always should be in the many side. So here you have the many side, right? So here you have a foreign key. And here's the many side, you have the foreign key. While here is the primary key. So the primary key is in the one side. And you can see it as if you're talking about the children and parents. So one, if we're talking about biological children here, a mother can have several children, but a child can have one and only one biological mother. So that is what you can think of. And then you have a children side, you have many, right? So this is a child entity, and this is the parent entity. And as I said before, the foreign keys are in the children entities. And database modeling language is used in DB diagram to do physical data modeling. And it looks like this. So you have customer entity. So the table is the customer entity. And you have attributes here. So each table is, you have the entities, right? And here is the attributes. And you can see this integer is the domain constraint. So this is what is allowed, right? We cannot put in strings in this quantity column. And you cannot mix the data types. So here you have primary key constraint. So this makes it into a primary key. So you saw the key symbol in the diagram. And here you have not null and unique. So not null and unique constraints. Email is unique, right? So actually email is an alternate key. So it's also a candidate key. We'll come back to keys in later, but it's a unique. So you could use an email to actually identify a row uniquely. So not null and unique constraint. And here you have the references. So this is the foreign keys referencing to primary keys in related tables. So they are referencing to the primary keys. So here you can see this one references. And this sign here means that it's many references. So it gives customer ID. And you have product or product ID. So then you get the many side in the order table. Okay, that's what this one means. And unfortunately, the unique constraint, it isn't implemented in DB diagram yet, so that you cannot see a difference in when you're making it into unique or not. So what you could do is that you also have the code, and you have the diagram, which should be the basis for your implementation. And the actual tables could look like this in the end. So you have a table here. This is the customer table. You can see the customer ID, first name, last name, address, and email. And this is the product table, and here you have the order table. So let's identify primary keys, foreign keys, and how they refer to each other. I will let you pause the video and let you find that out. Okay, so welcome back. So here we have the customer ID. And this is the primary key. Because this is the column that will uniquely identify each of the rows. And here you have product ID. This is the primary key. And you have customer ID is a foreign key. And this one references the primary key of its parent table or its related table. And these are the foreign keys. And foreign keys in the bridge table, it references primary keys in the related table. And can you figure out how much Ragnar Lodbrok needs to pay in total? Ragnar Lodbrok is this person. How much does he have to pay? Okay, thank you for watching this video. And In this video, you have learned how to do logical modeling and physical modeling. And in the next one, we'll go into example with Lucidchart and then with DB diagram so that you can see this in action as well. Yes, thank you. Bye.